Ladies and gentlemen, we are going to pick up again now. I'd first like to give you some technical information. Welcome to everybody concerning Bees Without Borders. It's an opportunity to know more about our association. You can find further information on bees.ch, FreeTheBees. Technically, the conferences are in French available, and you can get it in English or in German simultaneously. You can select under interpretation at the bottom of your screen. You can choose the language you would like to hear. Each conference is live and will last 40 minutes. And you can ask questions to either the speaker at the time or the next one. You can just refer to the different speaker with his name so we can pass on the question. We do not answer the questions live, but we will answer to all of those live later on. For the people who are listening now, who will not be able to hear it now, because maybe they're in another part of the world, you will get a link. So we will be able to put them online so you can watch them again as you wish. Thank you for this technical time. Hello, Dr. Laurent Larrieu. You are ecologist and forestry advisor. You conduct researches at the Institute for Agriculture in France, and you're one of the experts in Europe talking about the quality of trees. The theme will be cavities in trees are oases, ephemeral, essential resources for many species inhabiting the forest. So we already have your first slide on the screen. Fantastic. Hello, everybody. So I am going to speak about cavities who are in trees. And those are the places where you have honey-making bees who take refuge there. So I will place this in a more of a global context, and we speak about the tree microhabitats, tree-related microhabitats. So I will speak about the global concept, which is tree-related microhabitats, but I will try and focus on the cavities found in trees, because this is what is most interesting for when talking about bees. So these habitats, I would like to define them. They are morphological singularities that you find in certain trees, and you can find them in lots of different trees, and we can find them in living trees or dead trees, and their main characteristic is living environment. And to be a tree microhabitats, we have to look in detail what they would, what would they look like. Here you can see on the screen that you can find these habitats in different places of the tree. Some are on the trunk, some higher up in the tree crown, and you can find them in the branches. So I have drawn a circle, a red circle, around the cavities, because you find different diverse cavities, and they will interest all areas of the tree. We know different species who would be interested in these microhabitats. And you can see this represented here, the diversity of these different cavities. And you can see that we have tree microhabitats. You have effectively a wide variety of different insects. Here you can see the birds, the bats, etc. So you can see that these kind of cavities are interesting or are essential for many of these different insects, a wide variety. Right now, we can regroup 7 types of shapes of tree microhabitats. You have injury wood showing, you can have growth, dead wood, mushrooms, sporophores, slime and mold, the myxomycete in French, which are slime mold. These different 7 different shapes are regrouped in 15 groups and 47 types. So, for example, speaking about cavities, uh, in a wide, speaking widely, we have 4 different types, and these different cavities, when we differentiate them, we know that we have the knowledge of a different type that can be seen, which can be biological or physiological. And you can see the way they are associated with each other. So some will be a habitat for not very varied. So you have dendrodems, and we can see micro crustaceans, flagellates, mosses, insects. But if we take each group, for example, insects, we have communities which are diverse. We know maybe 15 different kinds of insects, especially dipteras, who will have characteristics which are very specific, with pH which are higher, oxygen which are lower. So we have a certain weakness of diversity of the communities linked with these habitats. But there is a specialty. If we look at the dendromens, we realize that we have 50% of the different kinds of insects which are strictly associated with these kinds of tree microhabitats. Now, speaking about an extreme, if you look on the left, you have a cavity, which is a certain kind of a bird, Tic épêche, who has about 10 years. And if we look at this habitat, we realize that there is a big and wide variety. For example, coleoptère of Esaletheride type, which are hard cup. And we have focused on checking what is the community linked with this cavity. Here you can see the predator and the insects he will be a predator for. And each one of these are located in different positions in this cavity. This type of cavity hosts a wide variety of insects. These tree microhabitats sustain a varied amount of biological functions, and really for different species, it really is a shelter, and it gives them the opportunity to have part in their cycle of life. And a species who will need to be dependent on that tree microhabitat, and it will be more of a dependency for them rather than one who would only need it for shelter. In these tree microhabitats, we have effectively um, the forestry realm. These habitats who especially have wood in decay, which are called proxylic, or who have faults, which means that the value of the wood is not as high. And one of our aims for years and years for forestry, they have tried to reduce those specific trees who have these cavities because of them not being as interesting on the market of wood. So the same kind of cavity could be considered as ecological places because they can have a, a role of being a habitat for them. And they have a role of conservation when speaking about biodiversity. So we can see clearly there is a conflict here. But about 15 years ago, we have managed to come to some compromise in between people who are maintaining and managing forests, and we have had PEFC or FSC standards who've been negotiated. But these are fairly questionable because they do not regroup all information. I'm not going to speak about economical sides, but the ecological side will be my focus, of course, today. Them being ecological objects. It seems strange or surprising. There is a similarity in between the bear and this Ilebriscas nommé, who lives in cavities at the foot of a tree, which is a habitat which is very evolved. My picture was to illustrate an oasis of ephemeral resources because this translates the reality of a tree microhabitat. We can see here three main features. It's a site of high quality site, but there is a sense of dependency. But that is nevertheless very important. Another feature is that these habitats are limited spatially speaking. So the spatial limit is clearly the size of the tree, because a tree microhabitat, it depends on the tree in which it will be found. And the third feature is that is temporary. If I take a microhabitat which is X type, one of the ways for it to be temporary is that it will disappear, and it will be, especially in exploited forests, it will disappear. And these will be, at the same time, those habitats will be eliminated. So what can we be? It could be developed. So developed from X to Y. This is the only dynamic series where we have certainties when speaking about microhabitats. We speak about barkless wood to a more evolved cavity with soil. For example, a piece of wood falls and breaks the foot of the wood. So it can't fix that wound or injury. And then little by little, as there's a sense of decomposition, and it will evolve uh, from a barkless wood, and a cavity will be created. And number 7, we will notice the wood will have be decomposed, and it will be in the heart of the tree, and a big cavity will have been produced. So each time I go from one step to the other, I will change. It'll be a different tree microhabitat. And this will have different specialties, or different, uh, there will be a process. When the tree is alive, for example, if it dies, it'll conserve his habitat, these microhabitats, and this depends on the change of climate, not drastic, but that change will be nevertheless important, and you will have a change of communities inhabiting them. For a tree microhabitat, it is available maybe for shorter periods. If you look at a cavity filled with water, which is called a dendrodème, and it will be important for certain kinds of animals, and the water will evaporate, and then will no longer be a dendrodème. And we can see in this kind of situation, it is not, it doesn't stay as such on as the time goes by. If we look at the genesis and the dynamic of these habitats, we can look and see, and we've tried to make a summary on this graph, and we can see certain things concerning cavities. And I'm not going to go into details, but you will be able to notice that there are different things which effectively will set certain things in motion. For example, around the roots, or in between the roots at the step, or you will have dendrodèmes which will appear, as you can see on the graph, where water will be collected, and you will have as well biotic or abiotic uh, situations. What makes it more complex, that we have a lot of different processes which are set in motion, which will set a certain change. And when there's no dynamic process, for example, in this situation where you have cavities in the roots. Very quickly, the dynamic processes condition the associated communities. And here you can see with my elateriate coleopteras, you can see what happens in these different cavities which evolve as time goes by. And as you can see, in the first and the second, we can see that this happens as well later in number 3, 4, and 5. And we notice only at the end and not at the beginning. So you can really see that it is always evolving situation where there is an evolution in time. Now, consequences, we will need to have a flow of tree microhabitats. and it has to do with research right now. Of course, we have to take in account there is a sense of density which changes in the forest, the distribution, the spatial distribution of those trees impacts as well the possibilities for these habitats. Now, these types of spatial distribution are not very well known because we haven't studied them very long, but you can see to the left the representation, the graphic representation. This is a 25-acre plot of land, which is in Ukraine, in Beech Grove, and we have made an inventory of all the trees in these 25 acres. And we have checked to see how many have these cavities. And we can see here the density of these different cavities. And you can see that they are very poor in a sense. And these are trees who have been in existence for hundreds of years. And we can see that they do not have many cavities, while other cavities have more of these cavities. So it seems like in these different forests, we have different areas where you find more prevalently cavities and others less. So when we look at these different trends, we can realize that there are trends of spatial distribution. And what we have noticed too is that forestry does modify those spatial distributions. Why would these pattern change of spatial distribution could impact the communities linked with the type of cavities? Because certain species linked with these habitats have a capacity of distribution which are relatively weak. If we consider that these communities work as meta-population, that they get extinct and then repopulated, we realize that we need the possibility to bring again these microhabitats so we can revive these species. If we take, for example, the example of Coleoptera cavicole, Caviculus coleoptera, we realize on the radiant, the capacity of distribution, speaking about uh, the different types of groups of coleopteras, they are capable to cover several kilometers so that they can recreate a new colony. But the caviculus coleoptera who live in those cavities have a much lesser ability to spread. If you look on the Limoneus violaces, we realize 200 meters, the distance of 200 meters from that cavity, the possibility to notice that same species to be found in a neighboring tree is fairly weak. So their ability to disperse is relatively low. So there should be the provision of cavities closer by, so the distance is no longer a threat, so that tree microhabitat could be created. So if our hypothesis is correct, We should have similarities when speaking about tree microhabitats. If the trees should be closer, we should have more possibilities for cavities. What we have noticed in an oak grove in France, which I spoke about earlier, and if we compare with a beech grove in Ukraine, what we notice effectively, there are similar assemblies in the oak grove that we haven't found in the beech grove. But clearly, the cavities found in beeches are different than the ones uh, carried by oaks. So in the oak grove, we put our focus on cavities in between 0 and uh, more kilometers. And then in the beech grove, the measuring rod was different. So if we look or consider things in a wider way, what we notice that these tree microhabitats are part of a very complex functional network. The species linked with these habitats, even the ones which have their cycle of life all comprised within these cavities, need extra resources. I will give you more details on that. The big example of complementation necessary, resource complementation, is when we take, especially, for example, the a lava in the soil, and they need within their cycle, they need a cavity. The majority of the adults are floricultural adults, and they need that so that they can fill their cycle of life. We can see other cases which are simpler. For example, a bats who lodge within these cavities, caviculous bat, and they need, for example, hydration, and they will need a cavity which has dendroderm with water in. And we have a certain caviculous hymenoptera, and they will need the flowers so they can therefore be fed. The supplementation of resources simply means have a resource which is similar or equivalent within a forest, and that supplementation of resource is really indispensable for certain species. So when speaking about a bat colony, if they have a lot of different cavities, this will have impact as far as predators or parasites, or will reduce parasites. And it will give possibilities for me to adapt to variations of the weather. The woods might be varied, or species might be different. And this will give me a chance to effectively buffer for these different situations. Very quickly, we will look at biodiversity associated with these cavities. What you notice on one of my first slides, you can have a wide variety of taxonomic groups associated with these cavities. Here you have a frog who is in a cavity at the foot of a tree, and you have gasteropods, moths, spiders, a huge variety of taxonomic groups. What makes it even more complex is that you have a whole network of users of these cavities. Here you've got different kinds of trees and different kinds of woodpeckers, and as well cavities, soil cavities, which have been maybe generated by an injury. And we can notice, looking at this graph, that two big groups who will be using these cavities, secondarily birds, for example, who are incapable of making their own cavity, they will reuse woodpecker holes. And then we have effectively other species who can only reuse pre-existing cavities. But you can have ducks or different kinds of birds who can use these different pre-existing cavities. And the network linked with this lasts over the time. Let's check and see which are the certain trees who more prevalently will have these cavities. The very big trees will play a big, will be very important in providing these tree microhabitats. For example, I have an example of a forest in the mountains. In this graph, you can notice you've got smaller trees going up to the bigger trees. You have the number of trees per hectare. The blue curve represents the percentage of trees in which you can find a microhabitat among the trees studied. And what we notice, the bigger the tree trunk, the diameter, we can notice that there is the potential for much more of these habitats within the bigger trees. The smaller, we can see that with a small diameter, you will not necessarily have those tree microhabitats. But the ones who are bigger than a meter, now the red line represents the contribution of each contribution when considering the whole forest. The bigger trees, which are lesser, of course, than the smaller trees, they contribute in the same way, maybe even in a bigger way. So the big trees really are very important here. Not only they contribute to the variety, but as well the diversity of those cavities. Here we can see at the bottom the number of trees needed so that we can see these different habitats. We had studied 8 different groups of microhabitats. And as we can see, if the curve, the line is thin or thick, it represents the bigger or smaller trees. What we notice is the bigger the trees are, you will notice that you will have more of a variety of types. But the category of size, the bigger they will comprise the more cavities, the diversity of different cavities. So there is a big need for, there's a huge need for these bigger size of trees. This graph is here to illustrate that all different types of tree reacted differently when speaking about tree microhabitats. Here you have the diameter where the tree has produced a cavity, and then you have the holes, the woodpecker holes to the right. And we can see in this graph that the oaks, different kinds of trees, and a lot of these trees, individuals of these trees, they can very quickly have these cavities happening. The diameters of the holes, the woodpecker holes, are pretty rare. So before being able, 5% of the population having had a woodpecker lodge, but we can see that you have variations. For example, you have the beech, for example, they can as well have these cavities. The mix of different trees, different kinds of trees, will offer as well very quickly the possibility of, in a quicker way, create these microhabitats. For example, the coniferous offer different kinds than the leafy kind of trees. This is a study to see if certain kinds of microhabitats would cohabit with certain types of trees. And what we have noticed in red, the cavities, soil cavities in the leafy kind of trees, if you have a woodpecker hole or a cavity, soil cavity, it will have more chances to have more of a variety on that same tree. On the coniferous kind of trees, we notice that these instances are lesser, but the woodpecker lodges might be found more often, or the soil cavities. Just for you to have an idea of the cavities, the tree microhabitats are very frequent in different forests, and in forests which have not been exploited, we notice that cavities in the bottom of the trunk, cavities, soil cavities, we notice that they, if you look at a density of, let's say, 10 centimeters per hectare, you can tell that there might be 12 different cavities per hectare, and the percentage of the holes, the woodpecker holes, are much lesser percentage-wise. this is approximate number, but nevertheless, considering the forests in Europe, these could be considered as correct. What we will look at right now is what are the impacts of the forestry on these cavities. What we noticed that when the forests are managed, it will reduce the cavities, the possibility for cavities. Now, the density of trees having these cavities are much lesser when the forests are managed. So you don't have the dendrodems, which are the holes which provide water. These two tree microhabitats, so clearly they create cavities after they have been sectioned. So when you get the trees out of the forest, you go with your tractor and might hit the tree, and there might be an injury. So by having an increase of the dendroderms or the wood without bark, we will have you will nevertheless have equivalent amount in these two different types of forests. But clearly, you will have in the forests some of the these kind of cavities will have lesser options to develop in managed forests. So when we consider the species which can take advantage of these cavities, for example, dendrodelms, they are a habitat which is very rare, maybe 1 or 2 per hectare. But in the forests which are exploited, you will have many more of these dendrodelms. So that will change the trends clearly. So if we look at the spatial distribution that we spoke about prior, reduce the density will effectively will have impact on the distance from one cavity to the other, and will be a prejudice for certain species. If you increase the presence of microhabitat, it doesn't add anything to diversity. It will impact negatively if we change or increase one or the other artificially. It will not add anything considering biodiversity. If we look at the population, if we look at oak, where effectively production to have a very high quality of oak, which would be used for making barrels, for example, the number of years is high, and there might be a lot of pressure put on these kind of trees. And you can see that every tree at that age within the population. If you look at the curve, when we spoke about the pine tree, for example, the fir tree, if you look at the diameter, it's exponential. Exponential depending on the age. But in our situation here, the proportion of trees wider than 70 centimeters that you find that there is a stagnation of those trees have lesser cavities. Now the control is different for leafy trees or for coniferous trees. For leafy trees, it is the person who indicates which tree should be cut. Clearly, these habitats are for the wood, the commercial value is lesser if you have those cavities. So he will establish which trees will have to be cut. But speaking about the coniferous trees, it is the diameter which comes in play, because the coniferous develop microhabitats later in their life. If, as a summary, we look at the impact of the management of forests, it can impact the opportunities for cavities to be present in the forests. This brings us to the fact that there are less and less of these cavities. So by reducing the density, so the spacing of these different species, the biodiversity linked to the managed forests is noticeable. Sometimes, however, you can see on the left that, for example, in beech or ash, for example, ash here, common ash. And we notice that by cutting off branches, and this will favor possibilities for fungus to be created within these holes. And as you can see here, it'll give a woodpecker the opportunity to create a hole. On the right, we have certain certifications in forests, and they might indicate we would like to keep this tree because it is rich in microhabitats. And they give opportunity for these trees who have holes, but they are kept and conserved and not cut down, and they are traced and kept. But it is not an easy work. In Italy, they have started to try and do this, and here you can see two photographies. These pictures were taken in Bavaria, where these cavities have been created artificially, and they have managed to be created. what they become is a dendroderm where water can be created only, which is not necessarily focus. And here you have as well sides which are covering the whole. So this is less easy for the species to access. I would like to recommend these 3 publications, which will give you a chance to study further this. To the right, you've got a pocket version of a book, and it'll give you different to the left, this guide de poche, and then in the middle, you have recommendations for people managing forest, and on the right, you can find on YouTube 25 very short YouTube films who speak about all these different kind. Thank you for listening to me. Thank you, Dr. Laurent Larrieu. That was very illustrated and very interesting. Have a wonderful day. We will take a break, a 5 minutes break. See you in a bit. Bye-bye.